Hello everyone, welcome to Tech Skeletons. I hope you all are doing fine, and today we are going to solve this problem, sort array of zeros, ones and twos. We are solving the fourth problem from the 450 DSA cracker seed by Babbar, and so this problem is a really special problem because when you look at the problem for the first time, you must be thinking that the best solution is to use any sorting algorithm, but let me tell you that it is not allowed. I mean, yes, you can solve this and your solution or your answer will be accepted, your code will be accepted, but it is expected that you will not use any sorting algorithm to solve this problem. To make it more clear or to make it more precise, you need to solve this problem in big O of n. Now if you use any sorting algorithm, it will take at least big O of n log n, but this problem wants you to solve it in big O of n complexity. Okay, so how we are going to solve this problem? Okay, so first of all I will show you a solution which is frequency based. That is, what you are going to do is you are going to count the frequency of all the elements. That is, there are just only three types of element present: 0, 1 and 2. So we are going to count the number of occurrences of 0, also the number of occurrences of 1 and the number of occurrences of 2, and then we will simply take those frequency, and suppose if 0 is 3 times, then we will we will change the first 3 value of array with 0. Okay, I will show you the code. I don't want to talk too much, so I don't think it is necessary to show you the input output, but still you can look at these two examples. You can see that the input is 11002201 and the output is sorted 000111122. Similar thing is here, 00010, so it is 000 and 1. Okay, now let's look at the first solution. So the first solution is in big O of n time, and it is big O of 1, that is we are actually using extra space, but that space remains constant and it does not change with change in the size of our array. What we are going to do, suppose we have example 1100222101. okay, now suppose this is our input. Okay, it contains only 0, 1 or 2, and what we are going to do, we are going to take a frequency array, an array for holding the frequency of 0, 1 and 2. So what we will do, we will take an array of size 3. Now when we take an array of size 3, it will have index from 0, 1 and 2. Now these index will give us the frequency. Initially we will initialize it with 0. We will iterate through this original array, and every time we find an element, we will increment corresponding index value. Like we have 1, so we will make it 1. Then again we have 1, we will make it 2. Then we have 0 and 2 times 0, so we will make it 2. Then we have 2 times 2, so we will make it 2. Then we have 1, so we'll now we have 1 2 times. Okay, so I'm just doing it in ones. So like we have 1 2 times, so at the end 1 will be like 4 times 1, and 0 will be 3 times. 0 will be 3 times and 2 will be 2 times. Okay, and after we have this array will look like this: 3 4 2. Now this 3 is the frequency of 0, this 4 is the frequency of 1, and this 2 is the frequency of number 2. Okay, now what we will do, we will simply take one at a time, and we will fill these. Like we will fill this original array with 0 3 times because the frequency of 0 is 3, then 1 4 times because the frequency of 1 is 4, and 2 2 times because the frequency is 2, and this is our output, this is our answer. Okay, so time is equal to big O of n, because we are iterating it once. Actually we are doing it twice, because once we are iterating and once we are taking these values also, and if big O of 1 time is consumed when we change the value, because we are changing the value for all of these. Okay, so it is actually big O of n plus big O of n, so it is actually, but it is always equal to, big O of 2n is also big O of n, if you know how this time complexity works. Like suppose we have big O of 100n, it is still big O of n. Okay, that's what it is. Okay, I hope you are familiar with this particular thing. Okay, so now we will look at the code. The code is very simple. This is a function, okay, and this function actually, this is void because it does not return anything. It actually modifies the original array that is given to us. This array actually contains the elements like 1 0 0 1 2, okay, or whatever the elements are, but the elements will be 0 1 or 2, and this is the total number of elements we have. Now what we are doing here, we are actually taking our frequency array, in which we are going to store the frequency of 0 1 zeros, ones and twos, okay, and here what we are doing, we are just building this frequency array, that is we are iterating over this array, and what we are doing, for each element we are increasing the frequency, okay. So if for this array will, at the end this array will look like 2 3 and 1, because we have 0 2 times, 0 2 times, then we have 1 3 times and 2 1 time, so it will be like this, okay. Then what we are doing, we are taking one variable k, and what this k will do, k is initially 0, because like, so if I take this array 1 0 1 0 1 2, okay, so k is 0 initially, okay, and we are running this loop from 0 to 2, because first we will take 0, then we will take 1, then we will take 2, and each time what we are going to do is, we are going to run for 0 the number of times 0 is present, we will run for 1 the number of time 1 is present, we will run for 2 the number of 2 is present, and at each step we will update the value, like we have 0 2 time, so we will make it 0, okay, and we will do k plus plus, so k will be 1, now k is here, okay, and since the value is 2, so it will happen once again, so it will be like 0 and then again 0, okay, so it is again 0. Now we have 1 3 times, so it will be like 1 1 1 and then 2, so this is going to be our final result, and k will update, k will increment simultaneously. Okay, I hope you understood. This is a very basic thing, okay. I hope you understood how it works. Okay, so it is big O of n time, and we are using extra space here, like this is an extra space, but this extra space is not increasing. This extra space always, we are always using an array of size 3. It will not increase even if our input array increases. Even if our input size increases, it is not increasing, and whenever that happens, it is considered as a constant space. Therefore our space complexity is big O of 1. Okay, so now we will look at yet another solution. So what we are going to do is, we are going to use the concept of partitioning. We are going to partition our array around 3 variables. Now what are those 3 variables? Those 3 variables are low, mid and high. Okay, I will explain you everything, don't worry. Just first of all, let's understand what we are going to do. What we are going to do, these are 3 variables we have, low, mid and high, and what we are going to do, we will always try, we will always try to move all the zeros to the left of low. That is, to the left of low there will be all zeros, there will be no 0 to the right of the low. Similarly, all the twos will be at the right of high. There will be no 2 to the left of high. Also there will be no 1 or 2 at the left of low, or there will be no 0 or 1 to the right of high. To make it more clear, any element to the left of low will be 0, any element to the right of high will be 2. And while doing this, all the elements between low and high will be 1, because 1 is the only element that is present in our array except 0 and 2, because we already fixed the position of 0 and 2. Now 1 will be in between of these 2 variables. Okay, so now I hope you understood that what I am trying to say. Now we will see the solution and the conditions that will help us to solve this problem. Okay, first of all, let me take one example. I will take the example that we had here, because this is a good example. It will give you a more clear idea about the algorithm. So 11 00 22 and 101. It is 11 00 22 and 101. So this is our array. Okay, I think I should write it in more spaced way, 11, 00, 22 and 101. Okay. Okay, now what we are going to do, we are going to take three variables, low, mid and high. I am naming them L, M, H, and we will initialize low to 0 and mid to 0. That is the start of the array. So low and mid are going to be here and high will be at the end, that is n minus 1, if n is the size of the our array. Okay, so what is going to happen here? Now we will always check the mid, and then, and according to the value of the mid, we will take the decision. Okay, now what decision we are going to take, I will write here. Okay, so this is our mid, value at mid, not the index of mid, but the value at mid. Let me write this, ARR mid. Okay, so when ARR mid is 0, we are going to swap the value at low and mid. But why we are doing this? As I told you, that we want to move all the elements to the left of low with 0. Okay, and currently we have mid at 0. Okay, so we found a candidate to be replaced with low. Okay, to be swapped with low. Okay, we don't want mid to point at 0, because the correct position of mid, the correct position of 0 is at low or to the left of low. So we will always swap mid with low if mid is 0. So we will do swap. I'm not writing ARR, I'm writing A only. Okay, because I want to save some time. Okay, and when we do this, we will also do low plus plus and mid plus plus. Okay, we will move ahead, because now our low is currently after swapping, the low will have 0 and mid will have the value of our low. So we will move ahead. Okay, we can move ahead. Okay, so mid plus plus. Now mid can be 0. The other value that mid can have is 1. Now what if mid is 1? Now let me tell you something very important. As I told you that all the values to the left of low or at low will be 0. All the values to the right of high or at high will be 2. So whenever mid is pointing at 0 or 2, then only we want to swap. Okay, so if it is 1, we will do nothing, but we will just move ahead. Okay, and the third value that we have is 2. Now if ARR mid is 2 or mid is pointing to 2, we will swap mid with high, because this is where mid the 2 belongs to high or the right of high. So we will swap that. So we will swap. Okay, we will swap array mid and array high. Okay, so we do this. Now there is a possibility, then we do this swapping. There is a possibility when we do this swapping, the high may had 0 in its place. Okay, so we will not do mid plus plus, we will only do high minus minus. Because it is possible that now mid have a 0 which we need to swap with low. So that's why we will not move mid ahead. We will not move the mid ahead. Okay, so now I think I should do a dry run. Okay, so what I'm going to do is I'm going to erase this, because obviously you will see the code in the next slide and it is written all over that what are the conditions. And so now I'm going to erase all this. Okay, because I want to dry run. Okay, we are almost done. Okay, so now let's do the dry run for this particular code. So our L is pointing, L and M is pointing to 0th index and H is pointing to the last index, as I told earlier. And what we are going to do is we are going to also I want to tell you one thing. You can go back to the video, you can take the screenshot of the table that I made here. or you can write it down on the paper and you can look at that conditions and what I'm doing here. Okay, so you will get a clear view of why we are doing all these things. Okay, so as I told you earlier that we will only look at mid and then we will take the decision, because our mid is going to give us a candidate for swapping, and there are only two candidates for swapping. One is 0 and the second candidate is 2. Only if mid is pointing to 1 or 2, then only we are going, sorry, not 1 and 2 but 0 and 2. If mid is pointing to 0 and 2, then only we are going to swap it. Okay, because that's what we want to do. That's how partition is going to happen. Okay, so what I'm going to do is I will modify. Okay, I will modify at each step because I don't want to. I will actually use some other color. Okay, so as you can see that currently mid is pointing to 1. Now what did I told you? I told you that if mid is pointing to 1, we will do nothing but we will move ahead. Now mid is pointing to this 1. Now again mid is pointing to 1, we will do nothing but move ahead. Now mid is pointing to 0. Now we got a candidate and we want to replace this 0 with low, because I told you that all the zeros are going to be to the left of low. That's why we will swap it. So this will become, actually let me, why not just erase it. Okay, so this is going to be 0 and this is going to be 1. Okay, now I also told you that when we swap it with low, we will move both mid and low ahead. Now low is pointing here. Okay, now low is pointing here. This is low. Okay, now mid is pointing to 0. Now 0 is a candidate for swapping with low, so we will swap it with low. This will become 0 and this will become 1. Okay, this mid will move here and this low will move here. Okay, this low will move here. Now mid is pointing to 2. Now I told you that when mid is pointing to 2, we will swap it with high. So what will happen? This 2 will become 1. As you can see that the high is currently pointing to 1. That's why this 2 will become 1. This will become 2. So this will become 2. This will become 2, and this will become 1. Okay, and this mid will not move. Why this mid will not move? Because it is possible that high was pointing to 0, and if we move the mid ahead, then we will lose a candidate. We don't want to do that, because if high was pointing to 0 before swapping, then now the mid is pointing to 0, and in the next iteration we actually want to swap it with low. Okay, that's why I will not move mid, I will only move high. Now high will move here. Now mid is pointing to 1. Now mid is pointing to 1, we will do nothing, we will move ahead. Now mid is pointing to 2, we will swap it with high. So it will become 0 and it will become 2. Okay, it will become 2. Let me actually erase this. It will become 2. Okay, and then we will move this high here, and this, now mid is pointing to 0. What did I told you? I told you that I will not move mid ahead when I am swapping with high, because high might be pointing at a 0 as happened here, and therefore we did not move mid ahead. Now we will swap this mid with current low. So this will become 0, this will become 0, and this is going to be 1. Okay, this is going to be 1. Okay, now mid will move ahead. Now mid will now low and mid both will move ahead. So low will be here. Okay, and mid is going to be here. Now both mid and high are here. Now we will again run loop, because we are going to run this loop as long as mid is less than equal to high. Okay, we are going to run this loop as long as mid is less than equal to high. Okay, because it is possible that at the last iteration we swapped it with high and both mid and high are pointing at the same point, but that value is 0. In that case we will swap it with low. That's why we are taking this condition. Okay, so mid and high both are pointing at 1. Now mid is pointing at 1, so we are good to go. So we will move ahead. There is no need of swapping. As soon as mid crosses high, we are done. Now look at our final array. I am going to write it here. So this is 0, this is 0, this is 0, this is 1, this is 1, this is 1, this is 1, this is 2, this is 2. We are done. We are done with our with this input. This is our final answer, and this is the correct one. So this is a great algo the time complexity is big O of n and space complexity is big O of 1. Okay, and we are not using any extra space, like in the frequency one we actually use some space, but that space was not increasing with increasing input, so that was a plus point. That's why we are taking big O of 1. That was our nearly equal to, but this is exactly big O of 1. We are not using any extra space at all. Okay, so now we will look at the code. So this is our code. Now let's look at the code. So this is a function which is void because it is not returning anything. It is actually going to modify the original array that we have. The size. We are taking low, mid and high, 0, 0 and -1 because low and mid are going to point at the first index, high is pointing at the last index. Now as long as mid is less than or equal to high, we okay, so I used a switch here. Okay, so I hope you are familiar with switch, how switch works. If you are not, you can use those if else conditions. It's all up to you because I already told you the logic, so I hope you can do that. But switch is a great thing, you should use this. This is a perfect place to use a switch. What we did, every time we check what mid is pointing to. Okay, so switch is a perfect one for this particular condition. We are checking what mid is. If mid is 0, ARR mid, sorry, not mid but the value at mid. If mid is 0, then we got a candidate to be swapped with low, so we swap it with low. We increment and we break. This is very important, break, because we don't want to run these codes. Okay, now if it is 1, we need not to do anything, we will move ahead. If it is 2, we will swap it with high, and high minus we break, and our array is modified. We are done. Big O of n time. Okay, so that's it for this video. I hope you enjoyed this video, and we will solve the fifth problem in the next video. Thank you so much. Have a nice day and take good care of yourself. Goodbye.